Dear friends, welcome to another very exciting edition of Data Science Tutorials. Myself, Dr. Suptik Mukherjee. Today's topic is random sampling using Python, random variables, and discrete probability. We'll also calculate the mean, variance, and standard deviation for a two dice rolled together problem. Now, before we move on to the topic, I have a small request. Please don't forget to subscribe our channel. We put a lot of hard work and effort in creating these videos. If you subscribe, it will motivate us significantly. Also, the Python notebook, including the code, has been uploaded in the GitHub repository, the link for which is provided in the description. Now, coming on to the topic. As you can see from the picture, we have many faces. If you want to create a random sample out of this, we can arbitrarily choose three faces, which I have done here. So that's my random sample. Now, if you have given a list of names and you are asked to decide, okay, choose randomly one name or choose randomly two names, then how do you do it? That's what I'm going to show you here. So, first of all, import this library, this module, random. Now, I have a list of names, which is Alice, Bob, Charlie, David, Eve. And then I am asked to say choose one name. Then I use random.choice and I pass on the list and store it as random name. Now I print the random name and it should print out one name, right? Randomly selected name is Eve. Now, here, now next thing is if I define a sample size, say I want two names, then I can do random sample and I have to pass on the list and I have to tell the sample size, which is 2 here. So it will print out the random sample, and this is what I'm going to get. I'm going to get a list of two names, David and Alice. Now, if I am given a dictionary which has a key value pair, so country and the athlete, USA Michael Phelps, Jamaica Usain Bolt, and so on, and then um, from that list, I am asked to choose one name or two names, then how do I go about? So first of all, we have to create a data frame. So I import pandas as PD and import random. So the data frame will be a list of the nation athletes, which is the dictionary. Dot items means the key and the value pairs, key and the value it's going to separate out. And I give the columns as nation and athlete. And that's going to define my data frame. So when I print the data frame, I get data frame representing an Olympic list, nation and athlete, the name of the nation, name of the athletes. Now, I have a data frame and I am defining a sample size too. So the sample size and then I'm asked to, then I'm trying to find two names. So df dot sample size, and sample size is 2 here. And then it's stored in random athletes. I print the random athletes and I get the two names right here. So if I had to find one athlete, I would have gone for df.choice instead of sample. Now, if I have to, I can do it another way. If I provide the fraction of athletes I want from the data frame. So if you have 6, if you say you have 5 here, 30%, 1.5, 2, right? Around 2 names I want. Okay. So now coming on to the rolling 2 dice problem. In the rolling 2 dice problem, say suppose I'm rolling 2 dice, then the outcome can be either 1 1, or first one is 1 and then 2 3 all the way to 6 for the second one, and then the second one is 2 and then third can be 1. I mean, second one can be, first one can be 2 and the second can be 1 2, 3, all the way up to 6. So the complete sample that I'll have here is 1 1, 1 2, 1 3, all the way to 1 6, 1 1, 2 1, 3 1, 4 1, all to 6 1. So totally is 36, right? So that's so if I sum them up, it's going to be 2, 3, 4, and then 2 and 4, 6, all the way to 12. So these are my random variables, or I can also call it um, my data point. Okay, so it's a random variable. Can also call it data point. Now, how to determine the probability? So there are 36 outcomes, right? So the probability for this is uh, so first of all, two. How can you get two? Only both are one. Both the dice are one. Then you can get two. So that means it has only one way to get it, and therefore 1 by 36. Total number of outcomes is 36. Okay, and then if you have say 3, you can get either 2 1 or 1 2. That means there are two ways you can get it. So it's 2 by 36. If you are trying to get 4, it is 3 1, 2 2, and 1 3, right? So you can get it 3 by 36. So that's how it's going, and you can get the probabilities, right? So now we want to find a code which can provide us the probabilities. So if to get a code which can provide the probabilities, say we are going to plot it and plot it as a histogram. So we'll get as a we import the matplotlib.pyplot as plt and define a function called calculate discrete probabilities. And what's going to be my outcome? Outcome is uh, so ij for I in range 1 to 7, which is less than 7, 7 not included, and so 1 2 3 4 5 6. And so uh, the outcomes because of these for loops will provide me that 36 sample space that I'm looking for, right? And then what I'm going to do is I'm going to define a dictionary called probabilities. Within the dictionary, what will be there? There'll be key value pair of that discrete the random variables or data points, whatever you call that, 2 3 4, and the how many times it is occurring. So total outcomes is length of all the outcomes, right? That is will be 36, the total value. Now for outcome in outcomes, so say 1 1 in the sample space. So dice sum is going to be sum of the outcomes. So 1 1 will become 2, right? So if it starts from 1 1, and we are running a for loop here. So then if this dice sum, which is say we start with 2, is in probabilities. So initially, there's only one way you can get 1 1, right? And so it's not going to be in the probabilities. So it will go to else. It is going to say that probabilities is 1. Otherwise, if it is say instead of 1 1, you have 1 1 is 2. If you have 3, 3 can be in 2 1 or 1 2. Then it will start with probability is equal to 1, and then next time, so for 1 2, say it is 1. So 2 1, it will go find itself in the probabilities, and therefore it will become 2. Okay, we'll continue from here. um, then we'll go to, I'll explain the program in more details. Dear friends, now let me explain the program in little more details. So we were right here, right? That uh, so we are creating a probability dictionary called probabilities, which will have a key value pair, which is the dice sum is the key, that is 2 3 4 all the way up to 12, and the probabilities. First of all, we need to know the count, that is 2 occurring one time, 3 occurring two times, 4 occurring 3 times, and so on, right? We need to know the count. And so we create a for loop for dice and count in probability. So it's the dice underscore sum is the key, and count is the value in probabilities dot items. So what dot items is going to do? It's going to split up the values in the probabilities dictionary in as keys and values. Now once we have that, then dice sum is the key here. So the for the key, the probabilities is going to be count is 1 divided by the total outcomes, which is 36. So probability for 2 is going to be 1 by 36. Probability for 3, count is going to be 2, and total outcomes is 36, so 2 by 36. Now once we define all this, then we return the once we define the function, what's going to be inside the function, then we return the probabilities. So return probabilities means we return that dictionary. Then within the main function, that means should run from the main function, right? We call the calculate discrete probabilities function, and we say this as probabilities. Then we plot the do a bar plot, so that is plt dot bar, and the x is the probabilities dot keys, y is probability dot values, and then we align the center. Then the x level is sum of two dice, y level is the probability, and the title is discrete probability distribution of two dice rolls. And the x ticks, which is basically what we are saying is this one, 2, 3, 4, 5, 6, 12, which is a range between 2 to 13, that is 13 not included, which is starting from 2 all the way to 12. Now we show the plot plt.show, and then we get the histogram. It's the probability distribution of two dice rolls, so we get the histogram. It shows that for sum 7 we have the maximum probability. Now if we come to how to calculate the mean, variance, and standard deviation for this problem. So what is a mean? So mean is basically the random variable or the data point times the probability. So the random variable or data point is the and the sum of it, right? So the random variable is basically 2, 3, 4, and all the way to 12, right? So if you say 2, corresponding probability is 1 by 36. Then we say 3, corresponding probability is 2 by 36. And so we take the product and then do a sum. So that gives me the mean. So what's the variance? The variance, we said, if we take a random variable, say 2 minus what you got, 2 times 1 by 36, right? And no, that we got the mean. So we have to calculate the mean. That's not 2 times 1 by 36. It's the mean that we got here, mu. So 2 minus the mean, and the square of it times the product for the probability for the xi, which is, say, we start with 2, and then we take the sum of all that. So xi represent data point, random variable, y mu is the mean of the data, and pxi is the probability associated with data point. Okay. So then the standard deviation is nothing but the square root of the variance. Now how do you codify this? So in order to codify this, you do the same thing as we had done before. So we define a function called calculate discrete probabilities. The matplotlib.myplot as plt as, and that has been already imported, right? So I'm not importing it again, this thing. And then what you do is you go to the same way that you define dictionary probability. The total outcomes is the length of the outcomes, which is 36. Then for outcome in outcomes, you define the sum of the outcome. For that means you go for each one of the data points, that is 2 to 12, and say no, you go from all the 36, you go across to all the 36, say 1 1 1 2 and so on, all the 36. So you say 1 1, then the data sum is the sum of 1 1, which is basically 2 to start with, say. And if this 2 is in probabilities, then there's only one way it can be there, so it's going to be 1. But otherwise you increment it, and then you find the in probabilities dot items, you find the data sum and the count, and then you return the probabilities. Now, in order to calculate the mean, what you do is you have the probability, um, which is coming from the so within the probabilities, which is this is going to return the probability. So within the, so you pass on this, the probabilities as your parameter within the while defining this function calculate mean. And the mean is going to be the dice sum times probability for dice sum and probability in probability dot items. So for dice sum and probability in probability dot items, whatever is the value, whatever is the dice sum is the key, and probability is the value, so key times value here. That means if you say probability for 2 is 1 by 36, 2 times 1 by 36, and you're doing a sum for all of them, and you return the mean. Now you go to the variance, which is dice sum minus mean square times the probability for dice sum and probability in probability dot items, and then you take the sum and return the variance. And then the calculate standard deviation, um, calculate standard deviation function will have variance as the parameter, and you take the square root of it times power to 0.5 means square root, and return that value. And then you call the main, and you call these functions one by one. So probabilities is equal to calculate discrete probabilities, then you pass on here in calculate mean to get the mean, and pass on the probabilities and mean to calculate variance to get the variance. Okay, pass on variance in calculate standard variance function, and then you uh, call it standard deviation. And so uh, so what's happening is, now if you print them, for first of all you are printing the probability and the dice sum, that is key value pair basically. For dice sum probability in probabilities dot items, you print it, and you get immediately this sum 2 probability this, which is 1 by 36, right? And then you get the mean, you print the mean and the variance and the standard deviation, and you should get all that as you have defined here. Okay, so that's all, friends. Thanks for watching, and don't forget to subscribe and comment and like, and happy learning.